In this work, influence of the interface between the laser-cladded metal layer and steel substrate on fatigue propagation of a short edge crack is investigated. In the picture, you can see the real bimaterial specimens when a thin metal layer is laser-cladded on a steel substrate. Here you can see the scheme of the specimen that was modeled. It is composed of the thick steel substrate and a thin laser-cladded layer. Moreover, an interphase layer is assumed to exist between the surface layer and the steel substrate. In the table, there are introduced the parameters used within the numerical simulations. Here you can see the numerical model and its properties. And here, the dependencies of the stress intensity factor range on the relative crack length for various values of the Young's modulus of the interface can be seen, together with the threshold stress intensity factor range and critical value of the stress intensity factor range. Moreover, the expected number of cycles to failure was estimated from the Paris-Erdogan law. Again, you can see the parameters used within the calculations and finally the results in dependence on the Young's modulus of the interface layer. From the results presented, it can be concluded that the unstable crack propagation is more likely when the interface layer is more compliant in comparison to the steel substrate. It is shown that if delta K1C was slightly lower, the unstable crack growth can be stopped after some time and the stable crack growth can occur again. When the interface is stiffer, for instance 200 gigapascals in comparison to 100 gigapascals, there is a 60% increase in the number of cycles to failure. Therefore, it can be summarized that it is very important to well know the elastic properties of the interface layer when the fatigue crack propagation shall be assessed.